Okay, so what's up everyone? This is Akshay here, and let us continue with the today's LeetCode purity question. Today's day is 395 along with the GFG purity problem. So let us read the today's question. It's a very easy and standard one. So valid anagram. So what it says is we have been given two string S and T. Return true if 2 is an anagram of S. So what is an anagram? It is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Okay, so they are saying that all the letters which are used in, let's say, string S must be present in T with the exact frequency as well, right? So if you see S is equals to anagram, so what is the frequency of A repeated? So it is A is repeated 3 times, then N is repeated once, then again it's A. So again this G is repeated once, and again R repeated once, and M repeated once, right? So similarly, if you check for the this string Nagaram, right? So again A is 3 times, so A is 3 times verified, N is 1 time verified, and G is 1 time verified, R is 1 time verified, M is 1 time. Now you can see we have covered all the characters as well, and all the characters has been present in this frequency of the string S. So that is why we can say both these two strings are anagrams, right? So how we can solve this question? First of all, what we can observe is that if the length is different, if length of S and T are different, then definitely that cannot be an anagram, right? So what is second thing, how we can check if the frequency are same? So we will make a length of size 26 array, uh, we will make an array of a length of size 26, right? And we will store A here till 26 will store the mapping of Z. Now in the question they have also said that it consists of only lowercase English characters, right? So we can go ahead with this approach, correct? So first we will traverse in the string 1, right? And we will increase the frequency. So for A it's 3, so I will increase 3. Then again for N would, let's say G would lie here, and let's say somewhere between M, R and everything would be there, right? So for G it would be 1, and what else? And N would be, let's say, someone between here. So M would be 1 again, N would be 1, R would be 1 again, right? So this would be the mapping of the array once we have traversed our first string. Now again we will traverse our second string, but instead of doing plus plus, here we did plus plus for S string. When we traverse in the tree string, we will do minus minus, right? So that this 3 again will become to 0, and every mapping will goes to 0. At the last we will check if any of the entry in this array is not pointing to 0, then definitely that's not an anagram, right? So that this question was very simple. Now please pause this video here, try to code this approach by yourself, and then we can see the code. Okay, I hope you were able to do this. Let us see the code now. Is the same we have done in the pseudocode and the dry run. First thing first, that we need to check the length. Then we have a frequency array. We traverse for the first time, incrementing the counters of the characters present in string 1. Then we traverse second time again, decrementing the counters for the characters present in string 2. And we are checking if any of the cells is having a value greater than 0 or not equals to 0, then definitely that particular string is not an anagram. So we say return false, and at the last, if no case is hit, so we have to return true. What is the time and space complexity? Time is again O of n, O of s, let's say max of, no, O of n, and n is nothing but the length of string 1 and string 2. What is the space complexity? O of 26. So ignoring the constant, it would be O of 1 as your space complexity. Let us look at the C++ code. So that is the C++ code here. Again, it's the same as we have done in Java in the dry run, so no need to extra explain it here. Great, solution has been accepted. Few last thing, that again, this is my DSA repository. You can start and fork to get help with the source code and social support. If you have liked the problem and understood the solution as well, then do like, share and subscribe. And until then, keep learning, keep growing. Bye bye and take care. Let us meet again in the tomorrow's streak of our LeetCode purity. Bye bye.